So we're going to start with a review of invertible functions. So we say that a function f is invertible, or one-to-one, if, well, there are a couple of things we could put here. So what I'd like you to do is pause for a second and write out how you can tell if a function is one-to-one. So here are two answers that you might have written down. So the first is just a definition of being one-to-one. For each output, it comes from exactly one input. You might have also talked about what's called the horizontal line test. Every horizontal line intersects the graph at most once. If either of these conditions are true, then we're going to have an inverse function. Okay, so we know if f is invertible, then f of x equals y exactly when f inverse of y equals x. So the inverse function swaps inputs and outputs. We can find information like the domain and range of f inverse by doing this swap. So for example, if we know the domain of f is x and the range of f is y, then those inputs and outputs are going to be switched for f inverse. The domain of f inverse is going to be y. And the range of f inverse is going to be x. If we want to produce a graph of an inverse function from the graph of a function f, we have two main methods. So one is just to switch our xy pairs. And the other is to reflect our function across the line y equals x. So in this example, if this is our function f, if we draw in the line y equals x, we're going to reflect across this line to get the graph of f inverse. Okay, and so this is how we doing this reflection, we take an original graph f and produce this new graph f inverse. Now let's talk about trig functions. I'd like you to start by drawing the graph of f of x equals cosine x. So take a moment, draw this graph. When we look at this graph, we can see that this is not a one-to-one function, and we won't have an inverse here. Right? If we draw a horizontal line, it's going to touch in infinitely many places. Okay, so even though this function doesn't have an inverse, if we were able to find a smaller interval on which our function was one-to-one, we would be able to find an inverse for a restricted version of our function. Okay, so I just wanted to write that down. So we know that our function is not invertible. What we're going to do is find a smaller interval on which f is invertible. And we'll, invertible here again means the same thing as one-to-one. And we're going to build an inverse for the restricted version of f. So what I'd like you to do next is to, on your drawing, find any largest interval on which this function is one-to-one. So again, you want to find any largest interval on which cosine of x is one-to-one. So there are lots of options for this domain, and some things that are not options. So let's start with some things that are not intervals that are one-to-one. So for example, if we looked from here at negative pi over 2 to pi over 2, here this restricted version of cosine is not one-to-one. However, if we looked at the interval from 0 to pi, we draw this in, we see that every horizontal line is going to cross this interval either 0 or 1 times. So we are one-to-one on this domain. Equally good is the interval pi to 2 pi. So if we look at pi to 2 pi, here this blue part this blue function is 1-to-1. Okay, and there are many more. We could continue doing it in this way. So there are lots of options. There is a conventional answer. So our convention is going to be to restrict cosine x to 0 to pi. We're going to call our inverse function arc cosine or cosine inverse. So according to our convention, this restricted version of cosine is going to have domain that is 0 to pi and range that, reading off of our graph, we can see the range is -1 to 1. And this one was invertible. It was a 1-to-1 function. Okay. The inverse function, cosine inverse, or arc cosine of x, is going to swap inputs and outputs. So the domain of this function is going to be -1 to 1, and the range is 0 to pi. And now we see why it's important to know what our convention was for restricting cosine, because the outputs of this function are given by the domain of cosine, so the domain that we chose for our restriction. So you're going to want to learn this interval. Cosine of x is going to be restricted to 0 to pi. That means that arc cosine of x, the inverse, is going to have outputs that are angles between 0 and pi. Okay. So I wanted to summarize what we'd seen about cosine on 0 to pi, which was 1 to 1, and then the inverse of that function. So even though cosine doesn't have an inverse, this restricted version of cosine does have an inverse, and we call it cosine inverse x, or arc cosine x. Here on the left, I've drawn y equals cosine x, and I've put in a couple of important points. So this is restricted to 0 to pi. If we look at the graph of the arc cosine x, we can get it in two ways. One of them is by switching x and y pairs. So for example, 0, 1 is going to be graphed at 1, 0. This point pi over 2, 0 is graphed at 0, pi over 2. And this point at pi -1 is, we switch the x and y pairs, and so we get -1 pi. All right, another way of thinking about how these guys are related is by looking at the reflection across the line y equals x, which is somewhere in here. So we can think about plotting y equals x and reflecting across it. So this point 0, 1 heads over to 1, 0. This long tail ends up on the other side. Great.